Okay, so I'm just going to kind of talk general first, and then I'll give you like an actual example, and hopefully it'll kind of tie it all together. So finding the areas, let's say I wanted to find so if I wanted to find the area under this parabola, between that and the x-axis, we could find this area right there. Okay, so we would be, so if this is f of x, we would integrate f of x from a to b, and we would find the area of that shape right there, or whatever. What's a shape? What does that look like? A muffin? A toaster?
Like
a piece of bread?
Toast. Yeah.
Yeah.
I'll go with any of those things.
What do you see?
Semicircle and rectangle.
Oh, you're such a geometry nerd. Like, look at the intersection
I
of
think about that for a very long second.
Okay, if I wanted to find the area of this parabola, start thinking about what kind of shape this is. If I wanted to find that blue area, and I call that g of x, we would integrate g of x from a to b, and that would give you that blue area, which is the shape of a I like it. Okay, so what if we wanted to find this area right here in green? How could I do that? Good, you could like find the area of the red so the area of the red minus the area of the blue, and you would get the green. So this green area is the red, and we could actually just put them inside the same integral minus the blue, and you would get the green from a to b. Okay, so you do not need two separate integrals. You could just combine them because you're just integrating that minus integrating that, and our boundaries of integration are the same, so you can just put them in one integral. Okay, so if you want to find the area between two curves, when you have one clearly bounding the top and one clearly bounding the bottom, you only need to just find the points of intersection, and that's your boundaries of integration, and it's just the integral of the top minus the bottom. That's it. So even if it went like this, where I've got this guy, and we'll go with this. Okay, can I do a top minus bottom here? Well, does it get messed up when it crosses the x-axis? Well, if I found this red area right here, is that going to be positive or negative?
Positive.
That's positive. It's above the x-axis. And then the area of the blue, in this case, is going to be negative, right? If I do top minus the bottom, if I do positive area minus a negative area, a positive minus a negative, it's actually adding areas. So the x-axis doesn't mess up at all. We can simply just do top minus the bottom, and don't worry if it crosses the x-axis at all. That will give you this entire total area, just top minus the bottom. Okay, so let's try an example. We'll do one that factors. So an example, let's find area between, we'll say y equals x plus 1 and y equals negative x squared plus 1. Okay, find the area between those two curves, even though one's a line and one's a parabola. So we're going to have to sketch. I mean, your calculator, you could use that to sketch, but these, I mean, this is just it's a line with a slope of 1, y-intercept of 1, so I'm just going to go like this. like I said, it's a sketch. The negative x squared plus 1, that's a parabola opening down with a vertex at 0, 1. So it looks like this. So you can see our intersection is we're trying to figure out. So it's important to know what the top equation is. That's our parabola. You can see that's on top, and our bottom is the line. But we need to do some algebra to figure out our boundaries of integration. So you can set those equal to each other and solve the system of equation. Move everything over. X equals 0, so we have 0 and negative 1 are our x values of our points of intersection. Right here and right here. We don't need to know the y value because we're integrating with respect to x. Top minus the bottom. So our integral would be our parabola minus our line, which is x plus 1, make sure you put it in parentheses, from negative 1 to 0. And that'll get you this area right there. Okay, and that's a pretty straightforward antiderivative. I trust that you'd be able to figure it out. You should get positive area. If it's above or below, you're going to get positive. If you get negative answer, then you chose the wrong one to be on top. So you just have to go back and you just make it positive and make a note wrong one on top, or just like rearrange these and you'll get the correct answer. Okay, questions so far? Okay, another scenario would be if you had a situation where it was not bounded by the top and bottom. It would be bounded by right and left. So let's say I have x equals y squared and y equals okay, x equals y squared. Anybody know what that shape is? It's an example. Find area. Good. Very good, Carter. So it's if you square root of both sides, y would be plus or minus the square root of x. So it's like a sideways parabola opening up to the right. Okay, so x equals y squared looks like that. Because there's y equals square root of x, there's y equals negative square root of x. Okay, negative x plus 2, y-intercept of 2, right here, and it's going down until it eventually hits right that we're looking for. What's the top equation? The linear? Like if you were to pick one or the other, I'd say linear is on top. Except, you see that right here, what's on top? This top parabola is on top of the bottom parabola. And it's not going to work for that little area right there. So there's not one. You could set up two different integrals, like a top minus bottom for this chunk, and then the positive square root is on top and the negative square root is on the bottom of that chunk, and add up the areas. But there's a better way. It would just be right minus left. So if you have a right minus left, it's clearly always the line on the right side. And it's always the parabola on the left side. So this would be a right minus left scenario. And you won't always be able to break it up into two different integrals and top minus bottom, top minus bottom. If you could do it this way or that way in this problem, but you won't always be able to. So you need to know how to do a right minus left. So if that's the case, if I'm finding this area basically of this line and then minus the parabola, you need to solve for y in your equations. Because we need to know what is this x right here. What is that x? Well, that is 2 minus y. Okay, so that x is 2 minus y, and this x is y squared. So it's the integral of 2 minus y minus the other x, which is y squared, dy. Okay, we're integrating with respect to y now. So our points of intersection, we need to know on the y-axis, from here to here, we need to figure that out. So, algebra time. I've got that x and that x, so I'm going to set them equal to each other. Y squared equals 2 minus y squared plus y minus 2, y plus 2, y minus 1. So y equals negative 2 and 1. Seems to check out on my graph from negative 2 to 1. So those are my boundaries of integration. Evaluate that integral and you have that area. That's a right minus left scenario, and if you do that, you're always integrating with respect to y. And you need to solve the equations for x so they can be written as a function of y if you're going to do that. Questions on that? Oh, we have time for me. I could make one up and you could try it. Let's I better, maybe I'll just stop there.